So x values used in a function that result in a real value. So some things we have to look for with this is if we have an even root. If we have an even root, then whatever is under the radical, we would say then the value under the radical must be greater than or equal to 0 anytime we have an even root. If it's not, then we're going to get a value that is not a real number. And we're sticking with the x values that are going to result in a real value, a real number. The other thing we have to watch for are fractions. If we have a fraction, the denominator cannot equal 0. If the denominator is 0, then the function's undefined. We can't do 5 divided by 0 or 10 divided by 0. Those are undefined values. So those are things we're going to be looking for when we work with these functions, when we add, subtract, multiply, and divide. We have to make sure that we're going to get real values. So we have to watch for even roots, and we have to watch for fractions. Odd roots don't matter. Scientific notation, this is always a times 10 to the n power. A has to be a number that's in between 1 and 10. N is always an integer. I don't know why they throw in scientific notation right here, but that's fine. That's what it is. Operations on functions. We're used to seeing it written like this, f of x plus g of x. We would know what that meant. That would just mean to add the two functions. But it can also be written this way, f plus g of x. A lot of times people will think this means to add f plus g and multiply by x. It does not. This means the same thing as f of x plus g of x. Same thing here. F of x minus g of x is the same thing as f minus g of x. It does not mean to subtract f and g and then multiply by x. Does not mean that. Same thing here. Multiplication can be written this way. Division can be written like this. If we're dividing, if we have a function like this, that function right there, I'm going to put a little asterisk there, I would have to say the domain is going to be that x cannot equal negative 2. Because if x equals negative 2, then I'm going to be dividing by 0. So for this resulting function that we get, we would say the domain is x cannot equal 0. If I wanted to write that in interval notation, it would look like this. It would go from negative infinity to negative 2, union negative 2 to infinity. Why would that be the same thing? Isn't this really the same thing as negative 2 to infinity? I'm sorry, negative infinity to positive infinity? Is that what this means? Go ahead, Steve. Yeah, if I don't use the brackets, it means that negative 2 is not included. Negative 1.999 is, and negative 2.001 is, did that backwards, this is actually negative 1.99, and this is negative 2.0001. Both of those would be fine, but not negative 2 itself. Alright, so let's look at some examples now. So they say in exercises 1 through 4, find f plus g of x and f minus g of x, and then state the domain of each. Then evaluate f plus g and f minus g for the given x value. Okay, we're not going to do both of these. We're just going to do the addition on this one. We'll alternate. Instead of doing plus and minus on every one of these, we'll do addition, subtraction, addition, subtraction. Okay, so I'll do the first one with addition. So if I'm going to add these two, I'm going to have negative 1/2 cube root of x plus 9/2 cube root of x. If I'm adding two functions, they have to be like terms. Well, they are because they're both cube roots. So if we have negative 1/2 plus 9/2, what's that going to give us? 8/2, which is 4 cube root of x. And then they just ask us to plug in negative 1,000. So it's going to be 4 times the cube root of negative 1,000. What's the cube root of negative 1,000? Negative 10. So 4 times negative 10 is negative 40. We're also supposed to state the domain. Well, because these are cube roots, it doesn't matter. The domain's just going to be negative infinity to infinity. I don't have to worry about even roots. I don't have to worry about fractions. I do have fractions, but they're already numbers. Fractions, we only have to worry if we have an x in the denominator. Okay, for the next two functions, we're going to do subtraction. We're just alternating addition, subtraction, addition, subtraction. So on this one, we're going to subtract. Now, if we are subtracting, I write my first function, but I have to make sure that I subtract this whole thing. So I have to make sure that I do minus 6x minus negative 3x squared. Make sure that you subtract both of those. So if I have minus a negative, that's going to turn into a plus right there. And so then if we have negative x squared plus 3x squared, that's going to be 2x squared. And then I have negative 3x minus 6x is negative 9x, and then plus 8. And so that's what we would get for f minus g of x. As far as the domain goes, I have to check, do we have any even roots? No. Do we have any fractions? No. So the domain here would just be all real numbers, negative infinity to infinity. And then the last thing we're supposed to do is plug in negative 1. Here's how that would look. F minus g of negative 1. That's how it would look. So then wherever I have an x, I'm going to plug in a negative 1 plus 8. So negative 1 squared is going to be 1 times 2 is 2. 2 plus 9 is going to be 11. Plus 8 is going to be 19. Easy enough, right? Okay, you guys go ahead and do number 3. Add them real quick. And then check your answer up here. Just adding like terms. After we get all the like terms added, we're going to plug 2 in for x. You should get 37. The domain, no concerns, because it's all just a polynomial function. All right, number 4, we're going to subtract. So we have 5 times the 4th root of x plus 1 minus negative 3. So that's going to be plus 3, 4th root of x. And then we have minus negative 2, so that's going to be plus 2. Again, careful when you subtract that you do minus both of those. So now I'm going to have 5 4th root of x plus 3 4th root of x. That's going to be 8 4th root of x. And then 1 plus 2 is going to be 3. So there's our answer for f minus g of x. Now, what about our domain on this one? We do have a 4th root. So what's our domain going to be then? Who knows? What's our domain if we have an even root? X has to be what? Greater than or equal to 0. Okay, so we can write it like that. Or we can put it 4 bracket 0 to infinity. Either one of those would be correct for the domain. And then, of course, just plug in 1. The fourth root of 1 is 1 times 8 plus 11, or plus 3 is 11. Easy enough, right? No problems there. Adding and subtracting, we're just going to combine like terms. Make sure you distribute the negative. Alright, so now we're supposed to multiply and divide on every one of these. We're just going to alternate. So we're going to multiply, divide, multiply, divide. Alright, so on this one, we're going to multiply. So if I multiply these two, I would have negative x to the third times 2 cube root of x. That's kind of hard to multiply that way. It might be easier if we think of it as negative x to the third times 2x to what power? If it's cube root of x, what is it? X to the 1/3. So now it's pretty easy to multiply. If we are multiplying, we need to multiply negative 1 times 2 is negative 2. X's, what do we do with the exponents when we're multiplying and we have like bases? What do we do with those? Add them. So I'm going to come up here and I have to do 3 plus 1/3. Get a common denominator. 3 is going to be 9/3 plus 1/3. So we add the top and the denominator stays the same. So it's going to be negative 2x to the 10/3. And let's just do the domain. They want us to plug in negative 64. Cube root of negative 64 is not bad. It's going to be negative 4. But then we have to do that to the 10th power. I don't know what negative 4 to the 10th is. I'm sure most of you don't either. But no one probably does. So our domain here, let's just talk about that. Do we have any restrictions on the domain if these are our functions and we're multiplying? No. So the domain is just negative infinity to infinity. Alright, so the next one we're going to divide. We're doing f divided by g of x. So f of x is 12x. G of x is 11x to the 1/2. So 12 over 11, that's pretty easy. But then what do we do with these exponents here, guys? If we're dividing, what do we do with the exponents? Subtract them. So 1 is going to be 2 over 2 minus 1 over 2. So it's just going to be x to the 1/2 on top. But, so we could say for this, x has to be greater than or equal to 0. However, look back here. Is x allowed to equal 0 based on this function here? No, it's not, is it? So our domain then should actually look like this. It should go from 0 to infinity, not including the 0. We're not allowed to use 0 because of this right here. Even though this is our resulting function, it still came from this. So x can't be 0. And then we would just plug in 4. What's 4 to the 1/2, everyone? 2 times 12 is 24 over 11. Okay, back to multiplying. If we're multiplying these two, guys, what do we have to do? 0.25. How could I think of that if I want to multiply it by negative 4? Think of it as 1/4. So what is 1/4 times negative 4? Negative 1. Remember again, we're doing f times g of x. So I get negative 1. And then what do we do with these exponents again when we're multiplying them? Add them. So I have 1/3 plus 3/2. Get the common denominator, 6. So we're going to have 2/6 plus 9/6. So that's going to be x to the 11/6. The domain. Look at our result here and look at the originals. What's the domain going to be, guys? We have an even root we're taking. So what's it going to be? Are we allowed to use 0? Can we take the square root of 0? Yeah. So the domain should be from 0 to infinity. It's not a fraction, so I'm allowed to use the 0. Let's go ahead and plug in 1. The 6th root of 1 is 1. 1 to the 11th is 1 times negative 1. It's just negative 1. Okay, last one from this section, we're going to be dividing. So we have 36x to the 7/4 divided by 4x to the 1/2. Well, 36 divided by 4 is easy enough, 9. What do we do with our exponents, though, when we're dividing? Subtract. So 7/4 minus 1/2. What's that going to be? 5/4. Good. So we're going to have 9x to the 5/4. And so that's going to be our answer, but let's go ahead and plug in 16. So what's the 4th root of 16? 2, and then what's 2 to the 5th? 32. And then 32 times 9? 32 times 9. Good, 288. So 288 is going to be our answer when we plug in the 16. And I could have written that as f divided by g of 16. That's how that's written. Okay. And our domain here is going to be, can we use the 0 or not use the 0? Nope. So it's going to be 0 to infinity. Okay, flip over on the back, or on page 147 rather. Okay, so it says the graphs of the function f of x equals x squared minus 4x plus 4 and g of x equals 4x minus 5 are shown. Which graph represents the function f plus g? Then what about the function f minus g? Well, if we wanted to find those functions, what could we just do with these two things? Just add them, right? Just add the two functions and figure out which one of those is correct. If I wanted to find f minus g, what do I do with the two functions? Just subtract and see which one's correct. But I want to show you another kind of cool thing that you'll use later on in pre-calc and calculus. Here's another way you can do this. Go to your calculator. Everybody turn it on because I want you to practice doing this. Go to y sub 1 and put in the top function. So x squared minus 4x plus 4. And then in y sub 2, put in the g function, 4x minus 5. Now, if I want to look at those functions right now, I can just hit graph, or zoom 6 to get the good screen, the normal screen. Here's what it looks like. What we want the calculator to do is to add those two functions for us. Watch if I can do this. Go to y equals, go down to y sub 3. We wanted to add the first function and the second function. What I do is I go under vars. Right here's vars. And I go to y bars, and I'm going to go to y sub 1. Plus, I go back to bars, and I go over to y bars, and I'm going to put in y sub 2. So I'm telling the calculator to add those two first equations. I can even turn them off. If I hover over the equals and push enter, now I've turned them off. I'm not even going to see those anymore. But the calculator can still graph the result of adding those two functions. So I hit graph, and here's what the resulting function looks like. So b is when I add them. I go back to y equals, and I say, okay, now subtract the two functions. So I'm going to just change my plus to a minus. Hit graph, and here's the result when we subtract the two functions. Okay? So that's not really a big deal for functions this easy, but you can figure if you had to add and subtract a bunch of functions and had to graph the result, it'd be nice to have this to be able to do that. So this one is, was this one the addition? Yeah, this is plus, and this is minus. All right, last thing here. The variable x represents the number of pages of a textbook to be printed. The cost C to print the textbook can be modeled by the equation c of x equals 0.2x squared plus 10. The selling price of the textbook can be modeled by the equation p of x equals 0.5x squared plus 20. They want us to find p minus c of x. So which one are we going to put first? C or P? P has to go first. The other class kind of messed that up. You have to have that first. Now we have to do minus C. Make sure you distribute the negative through both terms. So what is 0.05x squared minus 0.2x squared? Alright, negative 0.15x squared, and then we'll have plus 10. So that's our answer for P minus C of x. And then it asks us to explain what P minus C of x represents. What do you guys think? What does that represent when we subtract those two? What is it? Profit, yes. That's going to be the profit from selling one book, selling a book. We should make it a true sentence. It is the profit. Okay? Any questions? All right. Good job, guys. So on your homework, it's going to ask you to add and subtract every one from 3 through 7, and it's going to ask you to multiply and divide 7 through 15. I'm not making you do that though, okay? You can just add on number 3, subtract on number 5, multiply on 7, divide on 9, and then just do what I've got up there, okay? You don't have to do it, the whole thing for all of them. And also write the domain. Get used to writing the domain. If you've got an even root, make sure you do that. Or if you have a